Hello, we're going to talk about direct variation. What I want you to, let's see, aim is direct variation. And what I would like you to do is I want you to go to Desmos, and I want you to type in y equals, instead of m, we're going to use k, x plus b. And this is a line, and I want you to just hit, the K and the B are going to be the sliders, and I want you to fool around with the K and B. Right next to the K, there actually might be a little play button, and just hit the play for K and hit the play for B, and watch the line go out of control. And so you should say you recognize all these lines. Okay. Well, I want you to stop, and then I want you to set B equal to 0. So you now have this equation y equals kx, and I want you to hit play on the k and let the k go wild. And what do you notice about this equation? And what you notice that every single line, every line passes through the origin. Right? So we can draw a picture. I'm going to draw a picture here. And so you can just, fool around, just hit play and, and then just stomp it. So maybe one ends up being, the first equation might look like this. Here's the first equation. Okay, this is y equals 1.2x. Maybe, you hit play again, and then you stop it randomly. Maybe the second one is, here's another one. How about this equation? Oh, I guess, let's see if the red works. Here's another line. Right, here's another line that passes through the origin. Maybe this equation is y equals negative 0.83x. I try it again. Just for fun, right? How about this one? Here's another line. How about it stopped here, right? This pen's broken. Let me try a purple one. How about this line? This is y equals 7.6x. So in every case, we have these three equations, right? So we have y equals 1.2x, y equals negative 0.83x, and y equals 7.6x. In all these cases, if I divide everything by x, I get x equals 1.42. I have y equals x in this scenario is 0.83. And in this third scenario, I have y over x equals 7.6. In all three cases, we say that the ratio of y to x equals k. And if this is the case, then we say that y varies directly with x. The idea is you give me an x, I go right to y. There's no multiply, then add. It's just give me an x, I go right to y. And this simply is, hence the unit direct variation. Y varies directly with x, or y is in direct variation with x. The second you see varies directly, you know y over x equals k. So let's just look at some cases. So how do you know? So how can we determine if x and y have direct variation? Well, you'd be given a table of values. In the homework, you'd be given a table of values. So you get an x and a y, and maybe something simple. 1, 2, 3, 4. And you look at 3 as 5, 10, 15, and 20. So the question is there direct variation? You say, okay, what's the ratio of y to x? What's the ratio of y to x? So you're like, okay, 5 over 1 is 5. And 10 over 2 is 5. 15 over 3 is also 5. And last but not least, 20 over 4 is 5, right? So you see it, yes. So you would say yes. K equals 5 is the constant of variation, right? Because y over x equals 5, which can be written as y equals 5x. I think some of you immediately saw that. I think some of you immediately saw a rule and say, Mr. Adler, wait a minute, that's y equals 5x. Once again, they vary directly. Word problems. Let's see, word problems. Well, the first word problem, you might see if y varies directly with x and what did I say? And if y equals 2 when x equals 3, find the value of x when y equals, 12. Well, you're looking at this word problem, you see varies directly. You say, okay, y over x is equal to some y over x, right? Because all of these y over x's equal the same thing. That means they equal each other. We learned that from if a proportion is ratios set equal to each other. So you look at the value. They say, okay, we see here if 2 varies directly with 3, then 12 varies directly with x. So we cross multiply, 2x equals 36, x equals 18, right? Once again, you can put this in in decimals, you can put this in your GDC, but the idea is the second you see varies directly, you set up with a ratio, and you solve. Let's try another one. Let's see, number 2, y varies directly with x. If y equals 7 when x equals 9, find y when x equals, how about 21. Once again, you're reading this question and you say, oh, varies directly. You say, okay, y over x equals y over x. So if 7 varies directly with 9, then what y value varies directly with 21? Cross multiply. 9y equals, 147. divide both sides by 9. Is 147 divisible by 9? No, because 1 plus 4 plus 7 is not divisible by 9. But we know they're both divisible by 3. Final answer, 49 divided by 3. Let's take a look at a word problem. I'm going to hold the word problem up to the screen, and I'm going to ask you to take a screenshot. Let's do the problem with, let's talk about for a given speed. So can everyone sees this problem? Number 25. Number 25. If everyone can take a screenshot, please. Okay, now I'm going to read the question. For a given speed, the distance traveled varies directly with time. Kate's school is 5 miles away from her home, and it takes her 10 minutes to reach the school. If Josh lives 2 miles from the school and travels at the same speed as Kate, how long will it take him to reach the school? Once again, here's the question again. I'll probably put it up in the document. So once again, we see the word varies directly. Varies directly. What varies directly with what? Distance varies directly with time. Distance varies directly with time. So that means d1 over t1 should be equal to some d2 g over t2. Well, who's the first distance and time we're talking about? Well, we have Kate. So for Kate, our first distance is how far? It's 5 miles away, and the time is 10. Right? Now Josh is going to be D2. D2 is how far away does Josh live from school? 2. And the question is, how long does it take him to reach the school? So we say 5 over 10 is equal to 2 over, let's call it x. 5x equals 20, x equals 4. It takes him 4 minutes. Now, and those are the questions for homework. Just a quick thing, why are we teaching you this? Well, it's just an obscure topic. It's important. The thing is, if you think about it, we're talking about functions, but you're never going to see in your course the books call it a linear function. It's always called linear equations. Everything else is a quadratic function, exponential function. So you ask, why isn't it a linear function? Well, it's an extremely advanced topic, but the idea is that this is not linear because you have to multiply and then add. So that's called a theme. I'm never ever going to ask you that. This is probably the last time you'll ever hear it. This is a direct variation. This is a linear. This is a function. This is a linear function. That's technically not a linear function. Anyway, forget I told you that, and good luck.